Okay, so we shall explain the multiplication theorem on probability. Multiplication theorem. Multiplication theorem on probability. So here, if we have to find what is the probability of E intersection F, the probability of E intersection F means it is the probability of the occurrence, probability of occurrence of the events E and F simultaneously. E and F simultaneously. So this P of E intersection F, or it can be also written in this form, P of EF. Similarly, if we need to find P of E intersection F intersection G, suppose, if we have three events, so that also can be written as P of E, F, and G, and so on. So this will be called as, sorry, this will be written as probability. Okay. So uh, so this is what it is, a probability of the occurrence, probability of the occurrence of the events, probability of the occurrence of the events E, F, and G simultaneously. Okay. So now if you have to find P of E intersection F, then we can tell this will be P of uh, uh, E, P of F, then times P of E given F. Since we know that P of the value of the conditional probability, which is P of E given F, that is given as P of E intersection F divided by P of F. So we can write this P of E intersection F as P of F times P of E given F. Okay. And similarly, so P of E intersection F intersection G, now that can be written as P of E times P of F given E has happened times P of G given E and F has happened. Okay. So this is called as the multiplication rule, or the multiplication theorem, multiplication rule of probability, multiplication rule of probability for more than two events, for more than two events. And this is the rule, multiplication rule of probability for two events, E and F. Okay. So let us understand this by using one suitable example. Uh, so let us have, let's say, uh, we have a pack of 52, we have a pack of 52 well shuffled playing cards. We have a pack, we have a pack of 52 well shuffled playing cards. And from this pack, three cards are drawn at random. Suppose three cards are drawn at random. Okay. Then what is the probability that the first two cards are kings and the third card drawn is an ace? So what is the probability, it is asked, what is the probability that the first two cards should be is an ace, and the third one is a sorry, the first two cards should be kings. The first two cards are kings, sorry. um, okay. The first two cards are kings. The third one is an ace. Is an ace. Okay. So um, here it is told that the three cards are drawn at random and without replacement. Without replacement. It means what? It means that if we draw, say, the first card, then we should not replace that card. It means that after withdrawing the first card, we will have 51 cards remaining. And when we draw the first two cards, then we will have 50 cards remaining. It means after drawing the card, we should not replace it. We don't have to replace that. Okay. So here actually we need to find what is the probability that the uh, first first two cards should be kings and the third one is an ace. So it should be the probability of getting first is king and then one king and then one ace. Or we can write it like this also. What is the probability of getting king, then one king and then one ace? Okay, this we have to find. So um, first we need to find what is the probability of getting a king. What is the probability of getting a king in the first draw? Getting a king in the first draw. So that will be P of K. So that will be, so we know that there are four kings. So 4 by 52. So it will be 1 by 13. And then what is the probability? So this will be P of K, K and A, that will be equal to what is the probability of getting king, and then what is the probability of getting a king in the second draw given that king has been drawn in the first draw, times what is the probability of getting an S provided that two kings are drawn in the first two draws. So this we need to find actually. So find so probability of getting a king in the first draw, that is 1 by 13, and the probability of getting a king in the second draw given that king has been drawn in the first draw, that is equals to, now we have three kings remaining, and out of that 50 out of 51 cards, three are kings. So and then what is the probability that we have to draw an S given that two kings has been drawn in the first two draws? So that will be, so we have got 4S divided by, now 50 cards are remaining, so that will be 2 by 25. So therefore what will be the final answer? It will be therefore we have to find the probability of getting king in the first two draws and ace in the third draw. So that will be probability of getting king in the first draw times the probability of getting king in the second draw given that king has been drawn in the first draw, times probability of getting ace in the third draw given that kings have been drawn in the first two draws. So that will be, we have found it, first one is 1 by 13 and times P of K, given K, that is 3 by 51, and times that will be 2 by 25. So that will be equal to, that will be equal to so now that will be, So 3 will cancel out with 51. So it will be 3 ones are 3, 3 ones are 3, 3 sevens are 21. So 2 by 13 into 17 into 25. So this will be how much? This will be 2 by um 13 sevens okay. 13 sevens are 91 and 13 was a 13, 13 plus 9 plus 22 into 25. So this will be equal to how much? 221 times 25. So 25 ones are 25, 25 twos are 50, 52, 25 twos are 50, 55. So 2 by 5525. This is your final answer. Thank you.